and welcome to another science video test review. Today we are going to be talking about the water cycle. Okay, so let's go ahead and jump right into it. The first thing that we are going to be looking at is evaporation. What is evaporation? Basically what happens is the sun's heat and energy warms up this salty ocean water. Now this salty ocean water is made up of water molecules. Okay? So what happens when that sun's energy and heat comes down and warms up these water molecules? The water molecules start to move faster and faster. As they get hotter and hotter, they start to move faster and faster. If they move fast enough, sometimes they will escape the surface of the ocean water and actually turn into gas and start to rise. So it'll go from liquid into a gas as the water molecules start to move faster and faster because the sun is heating them up, and so they're moving around really fast. If you've ever seen your mom or dad, they boil hot water. What happens to that water when that blue flame is hitting it underneath, or when they're cooking spaghetti? The water starts to boil. It starts to move really fast because of the heat. You can even see steam start to rise from the pot. That's exactly what we're talking about here. That water is evaporating off of your mom or dad's cooking pot. Okay? So these water molecules start to rise in the air. The reason that warm air rises is because it is lighter. Okay? The reason it is lighter is because those water molecules are moving around so fast that you can't fit very many of them in a small area because they're moving around too fast. Whereas in cold air, because they do not have the sun's heat and energy, the water molecules start to slow down. If they're frozen, they're pretty much like this. I think they do move a little bit, even frozen ice. Even the atoms in like the desk that you're sitting on are moving very slightly, so slightly that you can't even tell. But all of these cold water molecules, because they do not have the sun, they move really slow, and so you can fit more of them closer together because they're not bumping into one another. So in this area, you can fit a lot more, and it's going to be heavier. If this was a bag full of marbles, and this was a bag full of marbles, which one would be heavier? It would be this one, because there are more in there. You can fit more in that given space. So the reason warm air rises is because cold air is heavy, it goes down, and warm air gets pushed upward. Okay? And we'll talk about this a little bit later in this video lesson when we start talking about warm and cold fronts. Alright, so you have this warm air that is rising, so that it pushes up these evaporated water molecules. Now what happens, the higher you get in the atmosphere, it actually starts to get cold again. Okay? So once you get up here, it gets cold. Now what happens, we already talked about, when water molecules start to get cold, they slow down and they come together. Basically, condensation, which is the second part of the water cycle, in kid terms means coming together, moving closer. So because it's colder, the water molecules start moving together. And in the atmosphere, there is a lot of dust and that sort of thing, so these water molecules actually start to attach to some of the dust that is in the air. What happens is this warm air continues to hold up these cold water molecules. They start condensing and coming together and forming clouds. Now what happens is this warm air eventually cannot hold up these big, heavy, condensed clouds anymore. When the warm air cannot hold up those clouds anymore, cannot hold up that water, it all comes down in the form of precipitation. Precipitation is basically water that falls from the sky in the form of rain, hail, sleet, snow, and that sort of thing. So the water comes down, and one of a couple different ways that salt gets in the ocean is that this precipitation comes down and it lands on a mountain, and as that water goes down a stream or a river, it actually picks up some of the salt from the rocks, and then it takes the salt right back into the water again. Well, not again, it takes salt into the ocean. The reason that salt never got evaporated in the first place is because salt is too heavy to get lifted up by the sun's energy. Salt is too heavy to evaporate. Okay, so it never travels along in this process, right? But the two different ways that salt got into the ocean in the first place is one, by picking up salt from these rocks. River picks up salt from rocks. Another way is by underwater volcanoes. Okay? Some of the magma comes spewing to the top in the form of lava, and when it cools and everything up here up at the top, the salt from the magma and from the exploding volcano puts salt into the ocean water as well. Here's some facts that you're going to kind of want to need to know. 70% of the Earth's surface is H2O. If you were to look at a map, you see that most of the globe, or a map that you're looking at, looks blue, filled with oceans, lakes, rivers, and that sort of things. Most of it is the oceans. But we also have quite a bit of water in icebergs. So 78% of fresh water is frozen in icebergs. All right, if you look at Antarctica, it's just one big old ice sheet. A couple things you're going to need to know for the test is that ice sheets are big sheets of ice, like Antarctica. Let me pull down a map here. If you see Antarctica right here, this is not an iceberg. That is an ice sheet. When this ice sheet chips off, and then you have little pieces that are floating in the ocean water, those are called icebergs. Okay? So ice sheets are the big things. Icebergs are the slow, large, moving pieces of ice that are traveling in the ocean water. But you can see here how most of the map here is blue. 70% of the Earth's surface is water. 21% of our fresh water is in lakes, streams, and rivers. Okay? So just by way of review, we talked about evaporation, condensation, and precipitation. Now let's kind of cruise back over here, and I want to briefly talk about warm and cold fronts. A front is just a large body of moving air. Okay? Now what happens is when you have a warm front, which is a huge body of warm air, it can be miles long. Okay? It can span 2 or 3 states. That's how big this moving body of air is. So if you have this warm front coming, and if you have a cold front coming, and they're coming towards one another, remember what we talked about earlier. The cold air is going to go down because it's heavy, and there's a lot more air molecules in that given area. So the cold air molecules are going to go down, and that's going to ramp the warm air up. So the warm air gets ramped up because it's lighter. The warm air gets ramped up into the atmosphere. So these fronts are coming together, the cold air goes down, the warm air gets ramped up. Now what happens is that when that warm air gets ramped up, clouds start to form over the middle of when these two fronts are coming together. So the two fronts come together, and then you have clouds that start to form where the two fronts are coming together. What happens when you have a whole bunch of clouds that start to build up? You start to have rain and storms. So something that you're going to need to know, definitely when we start getting a little bit more into weather, is that when you have warm and cold fronts coming together, you're going to get storms and rainy weather. Well, I think that's pretty much it here for the water cycle. Remember, these cold guys, they're cramped together. The warmer guys, they have lots of room because they're moving around from the sun's energy. And that is pretty much it. This is the water cycle. This should definitely get you guys ready for the test. And I look forward to seeing you guys in class.